started. Exponents. You guys know a lot of these things because we've talked about them throughout as we were doing radicals, but we're going to learn laws of exponents. So exponents can be used to write repeated multiplication in a simple way. So 4 to the power of 3 is actually just 4 times itself 3 times. It's way easier to write the 3 than to keep writing out a nice long string of multiplication. A power is a number written in exponential form, like we have down here. We have things that we call them. So the number underneath is the base. That's whatever is going to have something to the power of it. That power is called the exponent. And then the entire thing is called a power. We also have coefficients, which we've talked about in our previous lessons. Those are numbers that are in front of something that would multiply by the power. So, for example, what? What's the coefficient? 8. What's the power, or what's the exponent? 2. And what's the base? The base is just x. So what would be the power? The power would be the x to the power 2. Next one. What's the coefficient? There is no coefficient on this one. So the coefficient would be an invisible 1 at the front. There is no coefficient. What's the exponent? 3. What's the base? -7. Because it's inside the brackets together, it's -7 as the entire base, which means you want to punch in your calculators that as well. And what's the power? -7 to the power 3. Question 3. What's your coefficient? -2. That's your coefficient. What's your base? A times B is your base. Yes, AB. Jared, what's the exponent?
Exponent is 4.
Nailed it.
Because I was listening.
I know.
While I was talking.
Yes. Okay. Question. Can you wait till the end of the lesson? Okay. There it is. The zero exponent law method.
When you're like,
That's what we're going to learn about. Those types of rules. Jerry, Johnny. The zero exponent law. So, fill in the chart as you go through. 3 to the power 3 is what? 3 to the power 2 is what? 3 to the power 1 is? 3 to the power 0 is what? Is it 0 or is it 1? It's 1. -6 to the power 3. Do it in your calculator. -6 to the power 3. Yeah, we're gonna. Yeah, don't put the brackets because they're not there. So don't put the brackets. Leave it. -6 to the power 3. What is it? -216. -6 squared times. It'd be positive 36 if there was brackets. There's no brackets, so we're going to leave it as -36. If there was brackets, times right. If there's brackets, it's positive 36. -6 to the power 1. -6. And -6 to the power 0. Without brackets, it's -1. What if it had brackets? It's just 1. So what are we figuring out about this 0? It's always equal to 1. So if I give you something like this, and ask you to simplify it, the answer is just 1. I don't care what the base is. If it's to the power of 0, it's just 1. So you're going to have that come up constantly in this unit. You're going to have it where it ends up being to the power of 0. Just write it as 1. It'll make your life a million times easier if you remember that. It's how easy is it to work with 1. Easy. Next time you're out. The examples. Just keep going along. What's 6 to the power of 0? 1. Is the point getting driven through? What's negative 9 to the power of 0? 1. What's negative? That's in the brackets. Not in the brackets. What's it equal to?
Negative 1.
Negative 1. Two.
That's 2.
Oh, yes.
Look at this last one. That entire power is equal to 1, but then you have to multiply it by the coefficient. The coefficient doesn't change to 1. It's separate. So this you would evaluate like this. 2 to the power of negative 6 squared, 0. It doesn't matter if it's positive or negative, but is it negative 2? No. So you look at this entire thing. That's an entire power. And it's to the power of 0, so you know it's equal to 1. It's just equal to 2. Everybody good with that? Alright. Now we're going to learn a lot of confusing laws. They're real simple to remember if you look at each one of them individually. This sheet is going to be your best friend during this unit, so don't lose it. I think it's page 3. Page 3, I'm going to take a reference to that all the time as we do examples together. Page 3. So there's something called the product law. I'm just going to close this down so I can get my thing back. How many times do you drop your pencil in a day? A lot. Like literally, it's like every day, like at least 5 times class. Product law. Product just means 2 things multiplying by each other. So you have 1 power multiplied by another power. You add the exponents. Say, Johnny? We add the exponents. You can only add the exponents if the bases are exactly identical. They have to both be the exact same. So negative 6 and 6 aren't the exact same. Your bases need to be exactly the same. The next one, quotient law. You're also going to see it written as this. It's the same thing. That's division. So a to the power of m divided by a to the power of n. You subtract the exponents. If you were to subtract a negative exponent, what would you be doing? You'd be adding them. So we're going to see tricks like that all throughout, where it'll be dividing a to the power of negative 2. So make sure you're subtracting them. The next one, power of a product law. This one gets confused with this one. They're not the same. I can't draw off the sheet apparently. The difference is the 2 things being multiplied are your base. So you have 2 things. You have, say it was 2 times x. And then that was all to the power of something. That power can just sub into each part of the base. Does that make sense? So this m applies to both the a and the b. Any questions about that one? power of a quotient law. This is the exact same as the product law, except with division. Sorry, exact same thing as power of a product law, except it's division. So you've got two things that are divided by each other to the power of something. That thing can just apply right in. The m goes there, the m goes there. It applies to both the a and the b. We've used that before. That's what got us through our last unit. Power of a power law. Now you have a power, and it's to the power of something. You multiply the exponents. Let's do some examples. This one over here. A to the 3 times a to the 2. Reading a to the power of 3 times a to the power of 2. Which law is that? Yeah? A to the power of 3 times a to the power of 2. Which law would we use? Product law. And what do we do with exponents when we're multiplying two things then? Add them. Nice and simple. A to the power of 3 times a to the power of 2 is a to the power of 5. The examples match up with each other, right? So this one's your quotient, we're subtracting. This one's our power of a product. We've applied it into the 2 and to the a. You guys got that. Thank you. 3 to the power of 4 times 3 to the power of 2. It's asking you to simplify and then evaluate. So simplify it first. What law do we use, Jared?
Just like add the two spots together and then you make it one.
Yeah, so what would it be? 4 plus 2?
Yeah. Oh, 6. Sorry.
I'll get it.
Oh, close.
Yeah, that'll do it. Why would it be minus power 6? So when it's multiplied like this, you add the exponents. The 3 is your base. Your base stays the same. So the base here was exactly the same as the base here. So we haven't changed it. That's what allowed us to actually add them together. If the numbers had been different, we couldn't do that. Now we'll evaluate it. What does 3 to the power 6 equal to? 729. Next one. Which law is it? What law is it, Liam? Power of a product? Look at question. Look at page 3. Which one is it? Gabby. Power of a power. You got the right idea. It's just not what we call it. Yeah. Power of a power. So what do you do, Liam? Yeah. Multiply what together? The 2 and the 3. You multiply the exponents together. Liam's right. He's got it right. I'm just trying to get the right proper terminology. Oh yeah, you're doing it right. Yeah, you're good. You're good. Okay. So 2 to the power of 2 times 3 is what? What's 2 to the power of 6 equal to? 64? Yeah? Do you agree, Dawson? Our last example. What we're going to do together. What do we do? Which law is it? Page 3 will tell you which law it is. Which law is it? Fine, what law is it?
This, product one?
Quotient one, because it's division, right? So what do we do with that? We subtract them, so we get what? Negative 2 to the power of 3. Because 5 minus 2 is 3. Oh my gosh, and I'll evaluate it. Jerry, what do we get, man?
Type that in my handy dandy calculator. It's
Your handy dandy calculator is really, really slow.
alright. Just a second. It's an 8.
Negative 8.
I got sorry.
Yeah, no, the calculator got it. Right, it's negative 8. Do these ones on your own. I'm going to come around and get people to write their answers up on the board. Go back. They're fine on the outside. You could room to the inside, but then what's that? What's else? Yeah, my phone's broken, so I can't talk.
Sorry, you go on there.
What Jerry? Yeah, you add them. Just do the ones on the book, yeah. It is. Okay. First one. What did we do, Weston? Oh, because you came in. Yeah, sorry. Josh, what did we do to the first one? Sorry, Josh, I can't hear you. Everyone's talking. Hey. All right, Josh. For example 2a, you add 4 and 3, so it's just b to the power of 7. Next one is a little trickier. What do we do? Yeah, so what's your answer? X7, because what? Yeah. Ladies and gentlemen, you're going to fall for that trick. There's a 1 there. If there's no exponent, the exponent is 1. Please don't fall for that trick. We'll talk about it every day. And you're still going to fall for that trick. Because you're not listening. So what's the answer? Yeah. Next one. What do we do? Maya, what do you do? Same thing, add them up. So what do you get? B11. It's the same rule, it's just you applied it twice. 7 plus 0 is still 7, plus 4 is 11. Next one, what's our answer? What is it? E to the power of 12. How did you get that, Joni? You multiplied 4 by 3. Why did you do that? Yeah. Is it wrong if you put brackets around it?
Yes.
Why? So why are you so certain?
Did you multiply by times there? Yeah, no, gradient versus.
So Michael's saying he wrote the answer like this. Right? What do you say?
No, the 12 is on the other side.
Are those different? Are those different?
Yes.
They'll give you different answers?
Because
Because this brackets.
No, why not?
Not that one, it's the row positive.
Yeah.
I'll pause it.
Liam.
I'm taking a shot for if you put brackets around the whole thing, then this, well, this inside, there's got another number in there, that's fine. That's okay. I'll explain it.
I think I see what you're saying, but yeah. This way right here
This makes sense.
will give you the exact same answer as this way right here.
No.
It won't be different. So if you wrote it like this, you're good. Like that, you're good.
Yeah, I wrote it without brackets.
No brackets at all? That's how I did the first time? Also good.
So,
None of them make a difference. I'll answer your question in a second. You guys want to answer Joe's question for him?
Yeah.
Yeah, that's a good question, isn't it? Wow.
another drink. I got the cup.
Yeah, go get a drink. You guys act like a bunch of 6-year-olds.
I got the
Like literally, I have never seen a hiccup set off a group of 16-year-olds, so about 15-year-olds. Like that's crazy. What was your question, Joe?
Sometimes you should have brackets and
All right, that's Joe's second time asking the question. Want to answer it for him? Why not?
we're talking.
Oh, look at that.
Talking. Good job.
Joe, ask your question one more time. That corner. Try your best to listen.
Forget my question.
Yeah, your question was, doesn't it sometimes make a difference if you don't have brackets or do have brackets? And that's true because of the negative, right? So if you had -2, that would make a difference, right? So as long as you make sure that whatever that number was, so if we had a question that said this, it was to the power of 3, and then that was to the power of 2. Then you do the 2 times the 3 to the 6, right? And then you'd want to keep the brackets. That would make a difference. Okay.
So if it's negative, you want to ask that brackets.
If it's negative and it has brackets, you've got to keep the brackets so you don't make a mistake. If it's not negative, then it's not going to make much of a difference, right? The difference with the negative is you're going to multiply negatives by negatives, and they might cancel out if it's an even exponent. Emma.
So, like, with that one, if they, the 2 has, like, brackets around the negative, if you squared it, it would be positive, right? But if it doesn't have brackets, they always end up negative.
Yeah, because it's like you're doing, if you did this, we don't want that, right? So if you had -2 squared, what it's really saying is -1 times 2 times 2. So the negatives aren't going to cancel each other out. But if we had brackets around it, now it's saying -1 times -1. So it's, you have to add that in there. And now they'll cancel themselves out. Does that make sense?
Yeah.
Okay, down here, E. We got quotient law. What do? There's H3. Just subtract the exponents. F. We have it written differently. But what do? Still quotient law. Still subtract. What's your answer, Dawson? G. ST to the power of 6. What do we do here? Times this 6 into here and into here. So what's your answer? It's S6 and it's T6. Tough to right on a weird angle. S to the power of 6 times T to the power of 6. The 6 has to apply to both things. H. Now what do we do for H? We're going to do H up here so we can see it a little better. Oh. What do we do for H? The 4 goes to all of them? So then what's the answer real quick, Austin?
Negative 81 e to the power 4.
Just simplify, so you don't do the negative 81, but yeah, you're right. So all you do is, it wouldn't be negative 81.
I don't know, but I typed in something. Okay, somebody else.
Eric.
Negative 3 e to the power 4.
Negative 3 to the power of 4 times p to the power of 4 times q to the power of 4.
I'm confused like with the brackets. If the negative 3 was in brackets, they put another 3 brackets plus 3. So brackets are actually 3 and
Right.
like all of these.
And it's also around the negative, right?
So wouldn't it be like negative 1 times 3?
Yeah, so it's almost as if you've done this. So it's like negative 1 and then 3. Does that make more sense? To you, Emma? It's like that 4 is attached to that negative also. Let me write it like that. So it's negative to the power of 4, 3 to the power of 4, p to the power of 4, q to the power of 4.
And then
Right, yeah. So we just put the negative and the 3 together and put them around brackets so that we make sure to multiply the negative. Aaron and then Ella.
Why don't you keep doing the brackets?
That would be simplified all the way. I see what you're saying. So you're saying that we leave it like this. Like that?
Like inside of the bracket negative 3 e4 e4 and then bracket. Why don't you keep it like that?
Oh, I see what you're saying. So like this. Like that?
Yeah.
So the reason we don't do it this way, Johnny, because this is a great question, is that 4 now is only applying to the 3. This one right here would only be affecting the 3 because there's not brackets around the negative 3. So that would give you a different answer. Ella.
Why wouldn't it be like
Why wouldn't it be?
why wouldn't it just be a squared not x?
Oh, I can simplify it all the way? Yeah, you can simplify it all the way, but I don't think. Is it 81? I don't think. 3 cubed isn't 81. That's. Do 3 cubed. 37. Yeah, that's why I said it's not negative 81. Oh, I thought it was cubed. Yeah, so you're good. I'm wrong. Yeah. Oh, I thought it was cubed. I was doing cubed. It's awesome. You're right. Ladies and gentlemen, Dawson is right. Liam, take a step outside for a bit. Brayden, you want to join him? We'll get a drink where we can finish this lesson without me having to constantly stop for that corner of the room. Get it. Would it be positive or negative? Negative. Ah, Gabby got a question. So, do it in your calculator, in brackets. Negative 3 to the power of 4. Tell me what it gives you.
Negative.
It's in brackets, so it's not negative. Gabby's right. Yeah, it's tough.
Like, say when you know what change makes?
Cool. Okay, Joe. ask your question.
When we're doing like the entire rates, and if it was like the cube one, it'd be negative, but if it was the double, like if it was 2, it would just go from negative to 0. Do we use that for this one?
Yeah, it's the same way. So if it's an even exponent, the negative is going to cancel itself out. And this is why, because you had negative 3 to the power of 4. It's like saying negative 3 times negative 3 times negative 3 times negative 3. It's an even number of negatives. So they'll cancel each other out. So this negative will cancel with this negative, and this negative will cancel with this one. But if it was an odd exponent, then you wouldn't be able to cancel them all out like that. There would be one left over, which is why it's negative. So yeah, you're right. Emma, yeah? If you have a question, I guarantee half the room does too.
So when you like put it or in, you get rid of the bracket.
So if you brought this forward in?
No, I meant like in the whole bracket, like in the original bracket.
Yeah, you got rid of your brackets away from the P and away from the Q. Your negative 3 needs to go in brackets so that we keep track of our negatives. So if you had brought the 4 to just the negative, or just to the 3, then you would have had this, right? You would have had, your first one would have had a negative in front of it, and the other 3 would all be positive, which would change your answer. Now it's negative 81. Which is why those brackets are so important, right, Gabby? That's why Gabby got it right on her calculator. She put brackets around her negative 3. Those of you who weren't putting brackets were getting negative 81 as your answer. Aaron.
You wouldn't get negative 81, or even if it did, it's an odd, it's an even number, it's 4, negative 6, so you wouldn't get negative 6.
Right, these people were, because they were doing negative 3, and the calculator thinks, this is what the calculator thinks when you put negative 3 to the power 4. It's thinking you want to do negative 1 times 3 to the power 4. That's what the calculator's thinking. So that it calculates 3 to the power 4 is 81, but then it still has that negative 1. Then it goes to negative 81. That's what the calculator's thinking. You throw brackets around it, and now it'll do it negative 3 times negative 3 times negative 3. So your calculator's not very smart, right? It's just as smart as the person using it. Okay. I. What law is it? I down here is x divided by y to the power of 9.
What do they power of quotient law?
Power of quotient law? Yeah, so it's you. What do you get as an answer? Joe?
I didn't get that far.
Yep. So you brought the 9 into there and to there. So it's x 9 over y 9. So what do you do for the last one? Don't worry about it. It's not your issue, it's mine. You get c to the power 2 divided by 4 to the power 2, which is 60.
Yeah, that's what.
Yeah, exactly what Joe's going to say.
So can you just be like C2 over 16?
Yeah. C2 over 16. Aaron. No, let's evaluate them. When we simplify, yeah, change it. So punch in your calculator and make it 16. Let's just do that right now so everyone's on the same page. Questions? You guys, for the rest of